Okay, it just came in.
Okay, cool. Was it just one image?
Is it supposed to be
It was
two?
just that one?
It's this one right here.
Okay, I need to send the other one really quick.
Okay.
Okay.
All right, let's go over this first question.
Okay.
We're factoring what I call a second degree quadratic. The only reason I call it that is because it's got a number other than 1 as the coefficient for the squared term.
Mm-hmm.
These are definitely harder, but they can still be done relatively easier.
Yeah.
The goal is to split up that. Well, how do I split up that? Looks like you split it up into 3p squared and 3p. I don't know. But what two things would multiply together to give you 3p squared?
What two things multiplied what?
In other
Sorry.
words, you gotta separate the p's,
Okay.
but p times p is equal to p squared, not 3p squared.
Yeah.
So one of them needs to be 3.
Uh-huh.
Okay?
Yeah.
Now, when you multiply 3p times p, you're going to get 3p squared. And remember, this first term is always made up of that times that, nothing else.
Okay.
Okay? So, what's the next step? The way I taught you. What are the signs? Figure out both signs.
Figure out both signs?
That's the second step in factoring. Now, I understand.
Okay, so the first sign is
that this is a little different than the way you've learned. I can tell that you've learned a diamond method here.
Yeah.
Okay? Well, just listen to my method and see if it is a little better or a little worse. I don't care which one you use as long as you can come up with the answer.
Okay.
But the only way that a minus 5 can be produced is if the signs are opposite.
Okay.
Now, whenever the coefficient on that is different than the coefficient on that, well, then it means that plus minus is not the same as minus plus. So I have to allow for a minus plus also. You with me?
Not really. Like,
okay. If this was p squared only, and it was p and p, then knowing that the signs have to be opposite, I could get away with just plus minus. Because plus minus is going to be the same as minus plus. But in this case, plus minus is not the same as minus plus. Notice that whatever numbers I put there, that's going to multiply times 3p. Whatever number I put there is going to multiply times p. So the signs might be plus minus, they might be minus plus. They'll be one or the other.
Yeah.
But you don't know which at the moment.
Okay.
Okay? Now, the last step's fairly straightforward. What are factors of 5?
Just 1 and 5.
Yeah, 5 and 1. Okay? Now you have a trial and error situation. We don't have very many factors to try. It's either going to be 5, 1, 1, 5, 5, 1, or 1, 5. There's only 4 situations that can happen. Okay, so let's start by trying 5, 1. And at this point, it's totally random as to where you start. Okay, does that produce, how do you figure out the middle term? when you're factoring? In other words, what's going to give us negative 2p?
Oh, it's gonna be,
It's always made up of the outside and the inside.
I'm confused with that.
If you talk FOIL, then it's always the O and the I of FOIL. This is the inside, this is the outside.
What's FOIL stand for again?
First, outside, inside, last.
Okay.
In other words, when you multiply two things together that are binomials, that's the way you do it. You multiply 3p times p, then you do the outside, 3p times minus 1, then you do the inside, 5 times p, and then you do the last, 5 times minus 1. Well, when you do FOIL, the middle term of the quadratic is always made up of the inside plus the outside.
Okay.
Well, if I look at the inside here, what is plus 5 times p?
5p.
What is minus 1 times 3p?
Negative p.
Negative 3p. Add those two together, what do you get?
No, negative 2, or 2p. Sorry.
Aha. That's the right number, but the wrong sign. Whenever your first attempt gives you the right number, 2, but the wrong sign, is all you have to do is switch places. Move the 5 down to the negative sign. Move the 1 down to the positive sign.
Okay.
Now look what happens.
Yeah.
You do the inside, you get minus 5p. When you do the outside, you get plus 3p. Add those two together, you get the right sign and the right number.
Okay.
Okay? So that's the right answer. And now all I have to do is erase that and erase that. And those are my two factors. Okay? Now before we leave this, I want to go back because I want to illustrate something that's quite useful. And that is, let's say I started with a 1 there and a 5 there, which was one of my options. Okay?
Okay.
Now, if I check the middle term, I get plus 1p minus 15p. That adds to minus 14p. That's not the right number or the right sign.
Yeah.
So there's no need to try the 1 down next to the negative sign and the 5 next to the positive sign, is all that's going to give me is a plus 14p.
Okay.
So by the fact that I didn't get the right number means that I've eliminated one of my possible solutions. Now the solution has to be the 5 on the left, the 1 on the right, whichever one produces the right sign, which is the 5 down here and the 1 down there, that's what I go with. But you learn a lot by the first random thing you try.
Okay.
Okay? In other words, you learn whether or not you got it on the right sides or not. When I tried 1 on the left and 5 on the right, I could not produce a 2. I produced a 14.
Yeah.
So 1 on the left, 5 on the right can't be correct. The only other solution is 5 on the left, 1 on the right, and there's only 2 ways to do that. Check both of them and you got it.
Okay.
Okay? Let's try one more before I look at my email and see your other one. In other words, this is a second order also because the coefficient is not 1, it's 2.
Okay.
Well, step 1. Split up the ends. How am I going to split up those ends?
It's going to be is going to be 1n or 2n, yeah, and 1 or just n.
Okay. When you do that step, always multiply it back together again to make sure you get that.
Okay.
That says you've done it right. And that means you don't ever have to check it again in this problem. Okay? What are the signs?
Plus and minus.
Correct. And again, because this coefficient is different than this coefficient, it might be plus minus, it might be minus plus. Factors of 9.
3 and 3, 1 and 9.
I always start with those.
Yeah.
And my first attempt is always going to be the numbers that are closest together.
Okay.
So I'll just start with 3 and 3 randomly.
Yeah.
Does that work?
Yeah.
Hold on. What does it give you for a middle term? In other words, do your double smiley faces.
6.
This double smiley faces is really a valuable thing because it always allows you to check whether you factored something correctly. What are the two add together?
Oh, yeah, it's negative 6n.
Okay. Well, it's negative 3n. So we got the right number, but the wrong sign. What do we have to do?
Change the sign.
Change the location of this number. It goes with the negative sign. This one goes with the positive sign.
Yeah. That's
guaranteed to get us the exact same number we just got, opposite sign. Okay, which is what we wanted. We wanted that 3, but we wanted it to be a positive 3.
Okay.
Well, now it is.
Okay.
So we've got it right.
Yeah.
I don't think factoring needs to be any tougher than that. I don't like the diamond method. I don't like the California method. They're not necessary. They're confusing. They're hard. If you know them really well, I have no problem with you using them. I don't need to change the way you do it. But I can see from this step right here that that's not correct. Why is that not correct? Because 2n squared times minus 3n is minus 6n cubed. It's not that. So your very first step, always make sure that that times that equals that.
Okay.
Okay? All right. Shall we do another one?
Yeah.
I think so. I honestly don't think you can get too much practice at these. And these are the hardest ones you're going to face. I mean, when the coefficient is 1, they're really a piece of cake because then it boils down to a few rules, and that's all you need to do.
Yeah.
Well, the coefficient is not 1. It's more of a trial and error process.
Yeah.
First step.
So it'd be 3n plus or minus.
Just the first step. Don't worry about the signs yet.
Okay.
First step is to split up that.
Okay, and then n.
Okay, you've done the first step. Second step, determine both signs if you can.
Plus and minus.
No, plus and minus would not produce a plus 4. The signs have to be the same in order to get a plus number. Notice that whatever I put here and here is what produces this number.
Oh, okay.
So if I had plus and minus, that number would have to be minus.
Minus, yeah.
So
it would be 2 pluses?
Well, no. 2 pluses would produce a plus, but so would 2 minuses.
Yeah.
So the option is either, the answer is the signs have to be the same. Either plus plus or minus minus. How do you tell? Right there.
From that one? Okay.
It means minus minus. Because that's the only way to produce a minus as a middle.
Okay, yeah, okay.
Okay? So that's step 2. I've figured out the signs. Okay, now the last step is going to be easier on this problem because the signs are not opposite. They're both the same. So I don't have as much work to do. Well,
yeah.
Like I said, my first step is always trying the factors that are closest together. Does that work?
No.
Hold on. Do it. Don't try to do the whole thing in your head. Do this times this, then do this times this, and then add those two answers together.
Okay. 2n and negative 6n. That's negative 8.
That's the correct answer. So the first trial worked.
Yeah.
It frequently does if you use the factors that are closest together. In other words, most of the problems they give students with Common Core, they don't like to give factoring problems that are second-degree factoring problems where you have to use the two numbers that are furthest apart. 4 and 1 are further apart than 2 and 2.
Yeah.
Okay, so they like factors that are the close ones together.
Okay.
Let's try number 4.
Okay.
Until you get these down perfectly, I see no reason to work on anything else because there's just nothing going to be as important to you as being able to factor.
Really?
Yeah. Now, this one's a little harder. There's only 2 factors of that number, so that part's easy. But factors of 12 could be 12-1, 6-2, 3-4. So there's lots of stuff to try here.
Yeah.
But that's okay. We'll just use exactly the same system. What goes here and here?
5n and 5.
What is that multiplied together?
Oh, my bad. I meant n. My bad.
Okay. I'm just trying to get you used to, after you separate them, multiply them together again to make sure you started with what you started with. What are both signs?
Both signs are positive, so they're both positive.
Right. Both signs are the same, and they're positive because that's positive.
Yeah.
All right. Now we have to deal with all the factors of 12. We got those two, and these two. What I say always use the closest ones together.
So 4 and 3?
Let's try 3 and 4. Does that work? Tell me what middle term that produces.
3n.
No, that's just the n side.
Yeah.
Remember, it's the sum. You have to multiply that times that and multiply that times that and add your two results together. That's what produces this term.
Okay, so it'd be so when
What's 3 times 10?
It'd be 23n.
Exactly.
Okay.
So that doesn't work. But before discarding the 4 and the 3, let's switch them.
Okay.
Does that work?
Yeah.
It does.
Yep.
See, this really is a piece of cake. As long as you follow the same methodology each time.
Yeah, it's not that hard.
No, it isn't. I honestly think they do students a disservice by teaching them this thing they call the diamond method.
Yeah.
It just isn't necessary. I don't know. I mean, I'm not one to judge. I have confused some students before that knew the diamond method, and when I tried to teach them my method, all I did was confuse them. So,
yeah.
But let's go through this.
Yeah,
I think if we do a few more, you'll get it down pat. What's that?
I got it.
What's that?
That was kind of confusing at first, but I got it.
Okay, let's do this one. First step.
2b, 2b and b.
Okay. Second step.
Both pluses.
Third step. Those are the only factors of 5.
Yeah, so that'd be 1 and 5.
Does that work?
Yep.
Great. Let's do this one. You'll notice that they're a little easier when the signs are not plus minus. When they're both the same, you don't have as many different things to try.
Uh-huh. And that'd be 2n and n.
Okay. Sign.
And then sign both positive. It just maybe do the diamond method when it's not big numbers, where you have to find all the factors.
Well, with problems like this one, there's only one set of factors for 2. So you really only have one choice. Either it's a 1 and 2 or it's a 2 and a 1. So you don't
a hard
just
like other ones, like 196 and stuff like that.
That's different, but
it's funny.
Yeah, even that, I don't know if the diamond method makes it easier. But so what's the answer here?
Yeah.
It's 1 and 2 or 2 and 1? Which one? What produces that middle term? That's the question.
1 and 2?
Yeah. 1 and 2, because that gives you 1n, that gives you 4n, that gives you plus 5n.
Okay.
Okay. I mean, I'm not really vested in you learning my method over anybody else's method. The important part is, can you do it?
I can do that, yeah.
Yeah, I think you can do it with my method. This looks kind of hard. Let's just try one more. See whether or not, when they're harder, does that make it that much tougher to do? And I'm betting it doesn't.
Okay.
Start it.
So 7, A, and A. Both plus.
Now, whether you do this step over here or not is up to you, but let's talk about factoring numbers. Okay, how do I find all the factors of 28? Let me just give you a technique I use. I start by cutting 28 in half and doubling the other one. As long as I can keep doing that, I'm going to keep doing it. Can't do it anymore. I've got all the factors. If I could not cut 28 in half, I would try cutting it in a third, and then a fifth, and then a seventh, until I could cut it in a piece. And if I could cut it in sevenths, then I would multiply this by 7. Okay? And notice that that set of factors is actually 28 cut in a seventh, and then 7 times 1 gives you that. So here's our 3 sets of factors. And again, we could just randomly try them.
Yeah.
However, the one thing you'll notice is that that's a pretty good sized number. Probably not going to get there if I put a 2 there and a 14 there.
Yeah.
That's only going to get me up to 28. So there's some amount of logic you can use at this next step. I don't want to put a 28 there and a 1 there, because 28 times 7 is huge. It's not that big. Okay?
Yeah.
So let's start with the 2 factors closest together.
So 7 and 4.
does that work?
Let me see real quick. 7a plus 28a.
Yeah, you don't even need to include the a. It's 7 plus 28,
Yeah.
not 53.
No.
So it's not 7 and 4. The next step is to do what? Is it to apply a different set of factors?
Different set of factors?
No. The next step is to reverse the order. Because 7 and 4 does not give you the same answer as 4.
Yeah. Okay. Yeah.
Okay. So exhaust all the possibilities of these two factors.
Okay, so that's it. Okay.
That gives you the right answer. 4 plus 49 is 53.
Okay. That's not hard.
No, none of these are really hard. If they gave you something like the following, that would be hard. Why? Because there are tons of factors of 24, both on this end and this end.
Yeah.
So this could have a whole bunch of possibilities you would have to try before finding the right answer. And that's always going to be true, but what is also true is they're not going to give you this problem.
Yeah.
No way, shape, or form would you see this problem on a test. Notice that everything we're looking at here, there's only one way to factor that number. There's only one way to factor that. This next one looks a little hard because I could do 9 and 1 or I could do 3 and 3. But this number is either 7 and 3 or 21 and 1.
Yep.
Okay? But notice the way you did it. 9 times 3 is 27. So you didn't get the first term right. Always try to get that first term right.
That one, but yeah.
Yeah, this thing you do here where you factor it and then factor numbers out, that's never right.
Really?
Yeah. It might be that you have to factor a number out originally. In other words, if I have something like this, well, I'm going to take a 2 out of that right away because I can take the 2 out of every term, and now I have something that's no longer a second degree thing. I can factor that. That's a first degree factoring problem.
Okay.
So sometimes you do want to take that number out, but only from the beginning step. If you cannot take a greatest common factor number out of that, then forget about doing it at any point.
Okay.
Okay? And they may give you a problem like I just laid out, but they didn't here. Yes, they did. Before I hang up, let's look at 8 real quickly.
8?
Yeah. Notice that 8 can be simplified before I go to factor it, which is good because it's going to make the factoring a lot easier. That's divisible by 3, that's divisible by 3, and that's divisible by 3.
Oh, yeah.
So if I factor a greatest common factor out first, now I get a more traditional, easy.
Wouldn't that be 3K2?
Excuse me, sorry.
Oh, okay.
No, I'm glad you're doing that because that's the step I want you to do, is always be multiplying. In other words, when you're factoring, you want to always be multiplying, ABM. As you factor, you want to always be multiplying. Make sure that's 9K squared, make sure that's 66K, and make sure that's 21.
Yeah.
But now, this is going to turn into, my 3 doesn't go anywhere, but now I've got a problem that's a little easier to factor because this can only be 3K and K. It can no longer be 9 and 1. Well, my signs are the same and they're both positive, and this can only be 7 and 1. So what if I tried 7 and 1? That doesn't work. That gives me 7 and 3, 10. But what if I reverse it and try 1 and 7? Bingo. And you don't use that when you're checking the middle term. I use that and that.
Okay.
1 and 21 add to 22. So my final answer looks like this. It's three things multiplied together. It's the original 3 that I factored out, and then it's whatever this factored is.
Okay.
Okay. So always do that first step to see or not whether there's a number you can factor out before you go to try to factor the quadratic.
Yeah. Mm-hmm.
And I don't see these being difficult.
Yeah, no, definitely. I'm definitely
I don't see needing the diamond method even.
Yeah.
Even with these second order ones, where that's not a one, it's still relatively easy to do by what I call my trial and error method.
Mm-hmm.
And just practice them. If you practice a few, you'll get good at it, and you won't have any problems.
Yeah.
I didn't ever get your second email. I know our session's up anyway.
Oh, yeah, just the back of it. It's the same problems, though.
Okay.
So,
well, if you can do the rest of them.
Yeah, I can definitely do the rest of it.
Now's a good time for you to try it. In other words, once you've learned something, the best time to lock it in your memory is to immediately put it into effect. But even if you forget this technique, you can always go to the recording.
Oh, yeah, true.
In other words, I'm recording this. I'll stop the recording